this video, what we're looking at is a matrix question. So this question says that the determinant of the matrix is 6 2v minus 5 minus v is 24. Calculate the value of v. So we got the determinant, which is 24. Remember the idea behind the determinant, that is, we're going to find the product of the leading diagonal, which is that diagonal there, and we're going to subtract the product of the other diagonal right here. So determinant, which is a 6 times minus v minus 2v times minus 5. This is equal to 24. We were told that. So negative 6v plus 10v is equal to 24. So as we go, this becomes 4v, negative 6v plus 10v, that's positive 4v, is equal to 24. And solving for v, we would have divided both sides by 4. So v is equal to 6. So basically, we're saying if v is 6, then the determinant would be 24. All right, let us continue. This other question here suggests that the matrices L and M are defined as follows. We have L, which is 9, 5, 3, 2, and M, which is 3, 2. We were asked to evaluate the following. So we want to look at the matrix product LM, which is to multiply L times M. So L, which is 9, 5, 3, 2, and we're going to multiply that by M, which is 2, negative 4. One other thing about matrix is that we have to remember it's going to be the rows from the first matrix times the column from the second. So this is row 1 and row 2. And then here we actually have column 1. So the result of this is going to be like this. We're going to have row 1 times column 1, and then row 2 times column 1. So this is going to be the result of what we're about to do. So in row 1, we have 9, 5. So it's going to be 9 times 2 plus 5 times negative 4. So that is row 1, column 1. Since row 1 has exhausted the one column in the second matrix, we now move to row 2, which is 3, 2. So it's going to be 3 times 2 plus 2 times negative 4. So from this is our response. So let us just finalize this. This is 18 with a minus 20. And this is 6 with a minus 8. Finally, we're looking at negative 2, negative 2. All right, so that's the response from that matrix product. So now we want to find the inverse of L. Let us go back, take a look at what L is. So it's 9, 5, 3, 2. So let's grab it. The matrix L is 9, 5, 3, 2. Just want to make sure. Right? Making sure. 9, 5, 3, 2. All right, good. So remember, the inverse of L is going to be 1 over the determinant of L times the adjoint of L. So that is going to take us out. Now remember, the determinant of L is actually, again, it's going to be the product of the main diagonal, subtract the product of the other diagonal. So let us go about finding, setting up this. So the determinant of L is going to equal to 9 times 2 minus 3 times 5. So this is 9, 2 is 18, 3, 5, 15. So that is 3. The adjoint of L, so I'm going to set it up. The adjoint of L is to switch the elements on the main. So I'm going to switch 9 and 2. So the 2 comes here, the 9 comes there. and we change the sign on the other diagonal. So positive 5 becomes negative 5, and positive 3 becomes negative 3. So this is the adjoint of L right here. So all we got to do is to put 1 over the determinant. So it's going to be 1 over 3, and that will be used to multiply by 2, negative 5, negative 3, 9. All we have to do is to now do our scalar multiplication. So it's going to be 1 over 3 times 2, then 1 over 3 times negative 5, 1 over 3 times negative 3, 1 over 3 times 9. And then we finalize this. We're looking at 2 over 3, negative 5 over 3. We could cancel the 3 here, so it's going to be a negative 1 here. And we could cancel 3 into that 3. We got 3 here. So this is our inverse. 2/3 minus 5/3, negative 1, 3. There we go.